नमस्ते बच्चों, खुश रहिए। आज JVM Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in Vidyapeeth University and Faculty of Education and Methodology. So it's well known that you all are the students of the MCLE second semester, and your subject is networking programming. And today I will teach you the sessions. That session name is basically TCP Socket Option. Okay, so just before discussing this sessions, I just want to recall you that I have already discussed this session like the TCP sockets, what is the TCP socket, how to connectivity, how many functions are basically used in TCP, isn't it? And what is the sockets, what is UDP, many more sessions I have discussed just before this previous. So I today I will discuss this once again, and that is the similar with that session TCP IP sockets. Okay, so please read these sessions carefully, and for making it to you easy understanding, I'm just going to share some files. Okay, so wait 1 minute. Yeah, yes. Here, this is the TCP socket options. Here, that is similar to which I have discussed with you in the previous sessions also. On multiple previous sessions, the first and second session of this course. Okay, so here what? There are two socket options. TCP, we specify the level that IP protocol TCP. This is written like this: IP PROT underscore TCP. It means IP protocol TCP. Okay, here is the TCP max segment. SEG is the segment. Okay, socket options. What does this mean? The socket option allow us to fetch or save the message for the TCP connection. Isn't it? This is very well understood to all of you that TCP socket connection. TCP is basically used for delivering and receiving the data packets, or you can say that it is basically used for establish the connections between the communication between two or more nodes, isn't it? Uh, so this socket option allow you to fetch or set the message message for the TCP connections. The value returned in the maximum amount of data that our TCP will send to the other end. Isn't? So it is the message announced by the other end, and it is known as the signal message as well. Okay, unless our TCP choose to use the smaller value than the peers announced MSS. Mm, Peer announced in the sense peer is here like the what? There is various sender or the receivers, isn't it? So this is basically considered under the peer. Okay, sender and the receiver. Between that, you are using the sending and receiving the messages. Clear? So what? Here, this is basically the thing, and the synchronizations unless the TCP choose to use the smaller value than the peer announced result. If the value is fetched before the socket is connected, suppose value is fetched from the other units before the connection is established connected. The value returned is default value. That value is not the original value. The value will be the default value and will be used if a MSS option is received from the other end. Okay. Also be aware about the value is smaller than the return value. The value which you will be achieved, that value will be always smaller than the return value. Okay. So can actually be used for the connections if the time stamp option, for example, is in use because this option occupies the 12 bytes of TCP options in each sequence. So the maximum amount of data that our TCP will spend per segments can also change during the life of the connections, and the TCP supports path for these connections also. Okay, the maximum amount of data for our TCP will send the segment and also change during the life of the TCP supports and also discovery. Suppose if the root, if the peer in the sense node, if the root of that node getting changes, this value can go up or down. It's not always right that whatever the value you will get will be smaller than the return. Clear. So now we talk about the TCP node length socket option. Then what happened here? So if set this option disables TCP Nagel algorithm, in which what will happen? The purpose of Nagel algorithm is reduce the number of packets on your wide area network, whatever you are using, the number of packets will be reduced. The algorithm states that if a given connection has outstanding data, and the data that our TCP has sent, and for which it is currently awaiting an acknowledgement, then no small packets will be sent on the connection in response to a strike for the operations and until the existing data is acknowledged. Okay, so the basic definition is what? A small packet. A small packet is any packet smaller than the MSS. Okay, or you can also say that the main purpose of Nagle algorithm is to prevent the connections from having a multiple small packets outstanding at any time. So the two common generators of the small packets are the R login and telnet clients, since they normally send each keystrokes as a separate packet. On the fast lag, we normally don't notice the Nagle algorithm with these clients because the time required for small packets to be acknowledged is typically a few milliseconds, far less than the time between two successive characters that we type, that we also be type. Okay, and suppose if we connect here, example like we type the six characters strings like the hello, isn't it? There are six characters in this string. Uh, in this hello, there are six characters, including this one special also character, isn't it? So either the our login alternate clients with exactly 250 ms between each characters. The RTT to serve is 600 ms, and the server immediately sends back to echo of each character. We assume the acknowledgement of the client's characteristics sent back to the client's along and with the characters echo, and we ignore the acknowledgement that the client also sends for the server's echo. Okay? So this is the basic diagram which is same here. H E double hello and with the special characters starting with the zero, and they are reaching here with the echo, and this next one is a S. There is an interval of 250 ms. Okay, here I have told you that the start we exactly 250 ms between the each character. In each characters there is the difference between 250 ms. Okay, 0 to 50, 250 difference is 0. So after that, whenever the strings get all character gets what reaching, we assume that the acknowledgement of the client's character sent back to the client along with the characters echo, and we ignore the acknowledgement that the client sent for the server's echo. Isn't it? What is the meaning? That whenever client echo, then they will also receive as like the acknowledgement, or the you can say that the reply is, in the case of the reply, isn't it? So we will ignore this what acknowledgement and the reply. We also focus on this one. So each characteristic sent in a packet by itself, data sequence from left to right, and the acknowledgement is from right to left. Clear? Now here you see this one. If the Nagle algorithm enabled, we have the eight packets shown in this figure. You can see here you are sending the H, isn't it? And they are receiving. the H after the 50 ms. Then second, second EL, two characters will be already here reached, isn't it? Like the echo requesting. So EL is used here. What? Whenever they get the reply or acknowledgement for the first character. Then these two starts as the echo requesting, and when they get the what? They get the uh, acknowledgement. Then what two characters are left here? LO. LO characters are left for the echo requesting. Then these two characters comes with together for the echo request, and then he gets the here acknowledgement for the reply of that request. Then the last one characters which is left is again for the echo request, and they get the reply. This doesn't mean that the what is this one? Is this a get reply after this one? Is that it? No, it's not possible. Whatever this is not the phase. So whatever the uh, echo reply will be give by this at which points, that is the basic acknowledgement form. Okay. So the Nagle algorithm often interrupts the another TCP algorithm and delayed ACK algorithm. This algorithm basically causes TCP not to send the ACK acknowledgement immediately when it receives data. Instead, TCP will wait some small amount of time, and 40 to 200 ms they will wait, and only then send the acknowledgement. Okay, now the hope is that in this small amount of time there will be data to send back to the peer, and acknowledgement is big enough for the data. The problem is with other clients is whose servers don't generate traffic in the reverse directions, on which acknowledgement on piggyback. Their clients and direct noticeable delays because the client TCP will not send any data to the server until server delay acknowledgement timer expires. Clear? So client needs a way to disable the neglect algorithm, hence the TCP no delay, no delay options is getting. So this is all about your the TCP connection or TCP socket option, which in which connection and the getting the acknowledgement. I have discussed with you multiple options is here TCP socket. First is your the maximum segmentation socket options, and second is the no delay socket options, which I have already discussed with you with two example out here, isn't it? So I hope that this session is very clear to you. And if you have any doubt in this session, then please do query in the comment section box, and I will resolve this query in the next session whenever I will take. Okay, so read these sessions with multiple sources. Also use the report with multiple resources like the standard book for networking and also the networking programming, and also use the multiple online sites also. Please, and this use multiple resources also, refer multiple research papers also, which is associated with this one. Okay, and many query or questions will be arises with these stations like explain the TCP no delay socket options. What is this? Why it happens? Is it possible that we are not using these options? Clear. So, what is the options of the maximum segmentation? Why we are using the segmentations? Why we are doing the segmentation? The TCP socket option. Clear. So, please do these type of questions by your own, and if you have any problem in this, then I will discuss in the next session. Okay, thank you.